So for section 5.4, we're looking at sum and difference identities for sine and tangent. Remember that in 5.3 we dealt with the ones for cosine. Cosine of A plus B, cosine of A minus B. So we're just going to expand those and do the 2 for sine and the 2 for tangent today. Now, the sine are just like the cosine, just a different order kind of deal, so I'll show you those. Tangent's the one, the tangent sum and difference, if you're going to have any trouble, that's where you're going to have them, because they involve fractions, and sometimes they involve fractions inside of fractions. So you want to make sure you pay close attention and ask any questions when we come to those. Okay, so here are our sum and difference identities for sine. Notice that we have the sine of A plus B always equals sine of the first times cosine of the second plus cosine of the first times sine of the second. The sine of A minus B is always equal to sine of the first times cosine of the second minus cosine of the first sine of the second. Note the difference in those between the cosine ones. Cosine of A plus B had both of the cosines in the first term. And then it had the opposite sign of what you started with, and then it had both of the signs. So make sure you see the difference and make sure that when you memorize them correctly. So do you guys see the pattern, how different it is? Okay. So this one starts with sine, cosine, keep the sine, cosine, sine. So it alternates off. Sine, cosine, keep the sine, and then cosine, sine. So be really, really careful with those. Now let's look at the tangent of a sum and difference. And these are the two that people have a lot of trouble memorizing. The tangent of A plus B, two angles added together, is always equal to the tangent of A plus the tangent of B, all divided by 1 minus tangent of A times tangent of B. And then the plus and minuses just switch off when you reverse it to subtraction. The tangent of A minus B is the tangent of A minus the tangent of B divided by 1 plus the tangent of A times the tangent of B. So you need to commit all 6 of those. Cosine A plus B, A minus B, sine A plus B, A minus B, and tangent A plus B, A minus B. You need to commit those to memory and be prepared to use them.
Good.
Starting now. So let's use these to find the exact value of the sine of 75 degrees. Is 75 degrees on our unit circle? No. But we know that there are a couple of things on our unit circle that could add or subtract to 75. What are they?
30 plus 45 and 30.
30 plus 45. So we know that that would work. So I could rewrite this as the sine of 30 plus 45 degrees. Are there any other options?
No.
Is there anything else that we get into 75?
Not really.
You could go into quadrant 2 and subtract probably, right?
But that would be
Maybe,
fun.
but
It'd be more difficult.
it would be a lot more difficult and it would require some negatives. So if you can make them out of quadrant 1 angles, it is best to, but you are allowed to go into the other quadrants if you need to. So all we have to do is expand this out. This expands into sine of the first.
Are you allowed to go over 360 if you have to?
You are. But if I were going over 360, I would probably, before I start, just subtract it down.
That's
You know what I mean? Like if they were asking me for 835 or something, like I would probably just, I would probably subtract it back and then break it up. It would probably be easier. Okay, so let's see what the formula is. If we understand this to be A and this to be B, then it's going to be sine of 30 times the, hey guys, what's the formula? Times the cosine of 45. Do I change the sign or keep it?
You keep it.
You keep it for sine, right. Plus the cosine of the first times the sine of the second. Okay, so you have to be really careful, make sure you fill into your formula right. Sine A, cosine B, cosine A, sine B. Make sense?
Miss Hughes, wanting to see Kenny Cox.
Okay, so what is the sine of 30 degrees?
1/2.
1/2, very good, 1/2. What is the cosine of 45?
Square root of 2.
Square Square root of 2 over 2. What is the cosine of 30?
Square root of 3 over 2.
And the sine of 45?
Square root of 2 over 2.
Okay. So we have square root of 2 over 4 plus the square root of 6 over 4. And we will let them share. And I think we got the same answer when we were working section 5.3 on one of the problems, right? A lot of these look alike. You just have to be really careful with your radicals and really careful with your positives and negatives. Now, what can we do to check this answer since it is numerical? We could type it in our calculator. Yeah, we could type in, make sure we're in degree mode, we could type in sine of 75 degrees and make sure that that decimal matches whatever this decimal is. So be sure you check the ones you can. So now we want to find the exact value of the tangent of 7 pi over 12. And for me, the easiest thing, instead of trying to deal with all the fractions, is just to convert that to degrees. So I'm going to come off to the side, and I'm going to convert 7 pi over 12 by multiplying by 180 degrees over pi. I'm going to reduce the pi's, and then I have 7 times 180 divided by 12, which is one what?
105.
105? 105 degrees. Is that okay, you guys? So over here, that means I am looking at the tangent of 105 degrees. And the easiest way I think to get that is going to be what?
60 plus 45.
Yeah, 60 plus 45. Okay. Then I just expand it out using the formula tangent of A plus B. And that gives me tangent of A plus tangent of B. Is it okay if I fill in as I go? I don't have to write the formula down each time. Is that okay?
Mm-hmm.
All right. Over 1 minus the tangent of A times the tangent of B. Here's where things go bad. A lot of times here you're going to have fractions inside of fractions. So we just have to be really careful. What is the tangent of 60? Is it square root of 3 over 3 or square root of 3?
I think it's just square root of
Aw,
It's
now
square root of 3.
hold on, I have to come off to the side.
It's just
Sometimes I forget. Let's look. Okay, the 60 degree point is 1/2 square root of 3 over 2. And then the tangent is what we get when we divide the y by the x, right? So it's square root of 3 over 2 divided by 1/2, which is times 2 over 1. So you guys are right, it's square root of 3. So be careful with those. Like, I'm uncertain about those a lot, so I have to stop and kind of think about it. So this becomes square root of 3 plus the tangent of 45, which we know is 1, divided by 1 minus the tangent of 60, which is square root of 3, times the tangent of 45, which is 1. So I'm going to come up here. We're going to look at what we have so far. We have 1 plus the square root of 3 divided by, you have to multiply these two together, and what do they give you?
Square root of 3.
Square root of 3, yeah. So that's 1 minus the square root of 3. So we've made it that far. I've cleaned it up. We've done our multiplication. We can't add or subtract anything. We're just kind of stuck. Am I allowed to stop here?
No.
Why not?
You have to multiply with a conjugate on both top and bottom.
Very good. I can't stop because I have a radical in the denominator. And because it's a binomial, I can only fix it by multiplying top and bottom by the conjugate of the denominator. So, what is the conjugate of 1 minus square root of 3?
1 plus square root of 3.
Very good. All right. So I guess I'll go ahead and I will distribute the top. And that will give me 1 plus the square root of 3 plus the square root of 3, which is plus 2 square roots of 3. And then plus square root of 9, which is a whole 3, over. The denominator is nice because when you FOIL conjugates, what always happens to those outer and inner terms, those middle ones? They should cancel to 0. So this will give me 1 times 1 is 1. That gives me positive 1 square root of 3 minus 1 square root of 3 minus. So as I was saying before the interruption, the outer and inner terms cancel to 0, and the last times the last gives me minus the square root of 9, which is minus 3. So if I clean the top up, I'm now up to 4 plus 2 square roots of 3 all over negative 2. Now what's wrong? Now everybody's divisible by 2. And since I have a negative in the bottom, would it be okay if I just divided everybody through by negative 2?
Yeah.
And you could only do that if you can do all three of them, but we can. 4 divided by negative 2 is
-2.
negative 2, and positive 2 divided by negative 2 is negative 1 square root of 3. Now, I'm gonna, just right here, I wanna tell you guys, before we go any further, there is a problem in this section, and I can never remember which one, because when the different versions of the book come out, they change the problem numbers and the orders, and I haven't finished this yet, but one of them is wrong in the solutions manual and in the back of the book. It's like they didn't go far enough, and they didn't like foil properly or something. So if you get to that one, just be sure to ask me about it and we'll work it together. But I'll probably find it tonight. But just know, especially for those people listening somewhere else who are not in the classroom, one of them is wrong in the back of your book. Good luck finding it. For the last part of example 1, we're going to look at it a little bit different. We want to find the exact value of the sine of 40 times the cosine of 160 minus the cosine of 40 times the sine of 160. And you can see that in this case, we have been given the right side of an identity, not the left side. So that's okay. All we have to do is condense it back. Which formula is this? Sine times cosine minus cosine times sine. Is it sine of a plus b or sine of a minus b?
Sine of a minus b.
Right. That fits the formula sine of a minus b, which is sine of the first minus the second, right? Which in this case is 40 minus 160, which really they're asking us to find the sine of negative 120. So there are a couple of ways we could do that. We could just look at it and say negative 120 degrees would be here with a reference angle of 60, right? Nah, I lied. That's definitely not negative 120. You guys would agree with anything I said.
Quadrant 3.
Thank you.
I had to think about it for a second.
Okay, where is negative 120?
That is
Over here, right?
Yeah.
And that would be the 60-degree reference angle. Okay, that's one way to do it. The other way to do it is to add 360 to it and bring it around and make it positive. So what's negative 120 plus 360?
240.
240. So either way you go, you can see that it's over here in quadrant 3 and that it is 60 degrees past 180. Make sense? Okay. Then I need to know the ordered pair that corresponds with it. I know that 60 degrees has a 1/2, so in this case a negative 1/2, and the y value is also negative, so a negative square root of 3 over 2. And what's the tangent of 60 degrees?
4, 5, 3.
Square root of 3.
Square root of 3, yeah. So I wasn't asking for tangent, but I just thought it'd be fun to make sure we talk about it. And it is positive in quadrant 3. So which one of those is the sine value of 240 degrees or negative 120 degrees?
Negative square root of 3.
Absolutely. The y value of that coordinate pair that we know from our unit circle is our sine value. So negative square root of 3 over 2. How could we check it?
Put it in your calculator.
Boom! We could put our calculator in degree mode. We could type the original in, but be sure that when you do, you close off your parentheses. And it should be negative square root of 3 over 2. So I'm going to stop and save this, and you guys are going to check it and make sure we got it right.